Welcome to ClickMyProject.com. Now we discuss about the product for low power edge detection image sensor based on parallel digital pulse computation. Next we see the abstract for the product. A ever increasing apathy of the road development authorities in one of the major reasons for increasing road mishaps. Potholes trigger majority of such mishaps while driving in the night just to headlight might not suffice in assisting the driver to detect the presence of the pothole. Many other expected hurdles or the road apart from the potholes may cause severe consequences. Road conditions causes wastage of precious fuel, wear and tear of the tire and damage of the vehicle. All these reasons demand that the important to collect information of such bad road conditions and those a series of processing of analyzing the obtained information and appropriate calculation and derived, which in turn warm to the driver. In the information gathering phases, a vehicle with a camera mounted on the in front of n travels along the road, thereby the capturing image on the road. This paper aims to proposing the versatile pothole detection system which assists the driver in avoiding potholes on the roads by giving prior warnings. The basic idea of this system is to detect the pothole at the distance from the which driver is driving the vehicle to alert the driver if the pothole is arriving in the way of to reduce the speed and of the vehicle or take another path. This paper presents a detailed description of the system based on image processing developed to process and analyze the dataset captured using the camera mounted on the car that gives high efficiency and accuracy compared to the conventional method of pothole detection. Next we see the flow diagram for the product. First we collect the pothole road images and plain road images and to collect the data sets and to set the two reference images, one pothole and plain road reference images to set the database, and then browse any one of the selected image, then passing to the MATLAB and to convert the RGB to gray conversions, then write all the values to the text file, then all the text files data to be passing to the Xilinx software, then read all the data and passing to the memory section, then to identify the edge reduction for overall selected image. This edge reduction process to calculate the minimum value and set the threshold functions, then compare to the each and every pixel original values to the threshold value, then to set the replace 1 and 0 for each and every pixel position, and to view the edge reduction image for selected RGB image, then to identify the number of ones and zero count for overall edge reduction image. The reference image to calculate these all the things and to calculate the threshold value for the pothole image and the plain road image. Then compare to the each and every selected image to the overall reference image. If the selected the pothole image number of ones count and the equal to the selected image number of ones count, this the pothole detection system to be activated. If the plain road to be equal to the plain road reference image, is the pothole detection to be deactivated. These are the overall process for our pothole detection system using the VLSI. Finally, we see the output for the product for a pothole detection system. First, we select the any one of the selected image for overall dataset. This is the reference image for our dataset. These are the selected images. So select the any one of the image. So select fifth image and to convert the RGB image to grayscale image and to convert also the reference image. Then all the data pixel information to write to the any one of the text format. Then these are the text file for the image informations. Then we go to the sorting element. This sorting section to be set the threshold function. Just to run the threshold function level for our overall process. This is our the simulation structure. Then go to the minimum data distance. Then to run the minimum distance data sequence, finally you find the minimum data process for our overall selected input image. Then to identify the simulation based process for overall reference image and the selected image. Then the edge detection process to be run in any one of the output. This is the edge differentiation for the each and every neighbor pixel and the input pixel. Then to run the edge detection process, then go to the MATLAB functions and to select the selected image edge detection. These are the reference image edge detections. These are the part called reference image edge detection, part called plain image edge detection. This is the selected image edge detection. Then to identify the final output for the program. These are the display sequence for our plain or part hole detection to be detector or non-detector. These are the display position. Then to set the clocking sequence for just apply and then to run the clock, the display sequence to be display the detect section for overall output. These are the overall output for intelligent part code detection using VLSI technology.